In today's lesson, we'll be learning about the sine law. The sine law can be used to find angles in a triangle, such as this one, or this one. The sine law can also be used to find the side lengths of a triangle, such as this one, or this one. When using the sine law, you have to be very careful with your labels. Uppercase letters are angles. So uppercase A would refer to this angle, uppercase B would refer to this angle, and uppercase C would refer to this angle. Meanwhile, lowercase letters are used for sides. This side would be labeled lowercase a. This side would be labeled lowercase b. And this side would be labeled lowercase c. You'll notice that letters are directly across one another. At the very top, you'll see the formula for the sine law. It is a over sine A equals b over sine B equals c over sine C. If you remember, lowercase a refers to this side, lowercase b refers to this side, and lowercase c refers to this side. Meanwhile, uppercase A refers to this angle, uppercase B refers to this angle, and uppercase C refers to this angle. In our first example, we are given a triangle. We need to find this unknown side length. Before we begin, let's finish labeling this triangle. If this is uppercase B, this must be lowercase b. And if this is uppercase C, this side must be lowercase c. Before going any further, let's try to find angle A. I know it's not what we're looking for, but it may be useful to us later. Since we know this angle and this angle, we can work backwards to find this angle. If you remember, the interior angles of a triangle must add up to 180 degrees. So we can subtract 53 and 71 to work backwards. If you do that calculation with a calculator, you should get 56 degrees. At this point, we want to replace these variables with numbers from our diagram. Lowercase a is what we're looking for, so I'm going to leave that alone. Next, uppercase A, we just found it. It was 56 degrees, so we can write sine 56. Next, lowercase b is 4, so we can replace it with the number 4. Afterwards, we're going to replace uppercase B with 71 degrees. So I'm going to rewrite this as sine 71. And last, lowercase c. We don't actually know what lowercase c is, so let's just leave it alone. And uppercase C is 53 degrees. So let's rewrite that as sine 53 degrees. If you remember, we're trying to find the length of A. That means for sure we're going to be using that fraction. Now take a look at the fractions that are left. Which one do you think is going to be more useful to us? One which has both numbers in the top and bottom, or one where you don't know what the top is but you do know what the bottom is? I would think that this would be more useful to us. Down here, I'm going to rewrite my lowercase a and sine 56. If you put that into your calculator, you should get a decimal, and it's going to be approximately 0.83. Again, I'm going to put my number 4 right over here, and sine 71. You can definitely use a calculator to figure that out, and you should get approximately 0.95. This should look a little familiar to you. We're now going to use cross multiplication, which means we're going to multiply the numbers that are connected, and then we're going to divide by the leftover number. We can definitely do this calculation on the side. So 0.83 multiplied by 4, then divided by 0.95. You should get approximately 3.5. Therefore, the length of A is about 3.5 centimeters. In our second example, we are given a triangle and we need to find the length of A down here. Before we begin, let's finish labeling this triangle. If this is uppercase B, this should be lowercase b. And if this is uppercase C, this should be lowercase c. I know we're not looking for angle C, but we can do ourselves a favor and find it right now. It will be useful to us later. Since we know this angle and this angle, we can work backwards to find angle C. If you remember, the interior angles of a triangle add up to 180 degrees, so we can subtract 62 and 44. If you do that calculation, you should get 74 degrees. At this point, we want to replace these variables with numbers from our diagram. Lowercase a is what we're looking for, so let's just leave that alone. Next, uppercase A is 62 degrees, so we're going to rewrite that as sine 62. Lowercase b is 2.5 centimeters, so let's replace it with 2.5. Afterwards, uppercase b is 44 degrees, so let's rewrite it as sine 44. Lowercase c is right over here. We don't actually know what it is, so we can just leave it alone. And last, capital C is 74 degrees. So I'm going to rewrite it as sine 74. If you remember, we were actually looking for the length of A. That means for sure we're going to be needing to use that fraction. But what about these two fractions? Which one am I going to be using? Well, in this one, we both know the top and the bottom. In this one, we don't know the top, but we do know the bottom. So I think this fraction is going to be way more useful. I'm going to rewrite lowercase a, sine 62. You can use a calculator. That is going to be equal to approximately 0.88. Next, I'm going to rewrite 2.5. And instead of writing sine 44, I can use a calculator, and that's going to give me 0.69. This should look very familiar to you. We want to solve this by using cross multiplication, which means we're going to multiply the numbers that are connected, then divide by the leftover number. I'm going to do that calculation over here on the side. So 0.88 multiplied by 2.5, and then divided by 0.69. And that's going to be equal to approximately 3.2. Therefore, the side length of A is approximately 3.2 centimeters.